Here is speedrun of the Backgammon Excel Esports case. The lambdas and VBA I'm using, you can download its link in the description. For level 1, I got to identify pips and multiply by how many there are, this named range, calling that WC for white checker. So if the leftmost of these is a white checker, then I use the white multiplier, otherwise the black multiplier. And then the count of these, right? So if this is a 0, then 0, otherwise the length of this. And if I just, sum product these, that should give me the number of die pips needed to get everybody home. So for level 2, it is time for us to play the game of backgammon. So we've got these rolls. Die pips of this is my custom lambda. I got to sort these because you always use the bigger one first. So I'm going to sort them descending. And I'm going to make them a row. And there are the dice, right? So now over here, I'm going to use X2call. For now, this is the same as a regular 2call, but I'm going to start using some of my fancy stuff later. All right, so this, I just need no addresses. So this is all the dice. You go one die at a time. You do not add them together in backgammon. I need to track the state of the board, which I'm going to do like this, right? So take this here, right? So the length of this is how many pieces I have in each cell. Gonna, give myself a little bit of room here. So I need to know what the furthest distance any checker is. I need to know in exact space rolled. So for example, if I rolled a 4, how many are in space 4? I need to know where I'm moving from, where I'm moving to. I need to, then I know if I'm done, and I look that up on the turn number, right? Because that's the answer there. So the furthest distance is, I'm going to X match true on here, just looking for the first one that is greater than 0. Right? So that, and then, so that's the first item in this array, right? So that corresponds to the space 7 minus that. So that space number 6 is my furthest piece away. So I look up the die on the space list, right? Which is locked, and look that up here to know how many checkers I have in the space that I rolled, right? 4 in this case. So move from, so if I have checkers here, then I move from the space I rolled. Otherwise, I move from the furthest space. That's what the rules say. So I move to simply where I started, minus number on the dice, 0 representing off the board, 0 or less representing off the board. If so, this is my board at the start of my move. At the end of my move, if this X match gives me an error at the end of my move, so if that is an error, that means they're all 0 and I'm done. And then the turn number is a sequence. I think you could have up to 160 in this one. It's not going to take that much. Yeah, but it is. It's 80 times 2, so 160, one column, starting at turn 1 and advancing by half a turn, right? Because each of these dice is a half a turn. So I need to update the board. So that is the previous step plus if I'm moving from that space, So if that equals this, then -1, right? I subtract 1 for moving from the space. If I'm moving to the space, right, that is in what, X, staying locked. Then I move +1, otherwise, these are both zeros, right? Otherwise zeros. So that updates the board. There used to be 4, now there's 0 spaces in this. Now there's 0 checkers in that space. So here I do all this, and then I simply need to look up being done, right? A 1 represents being done on my done. I look up on my turn indicator, and I only want the integer part. The half turns don't count. So 9 turns to finish that game, which, you know, sounds right. Level 1, level 2, both right. Okay, so level 3, it becomes a 2-player game, but the black and the white pieces can't interfere with each other. So instead of a 2-player game, I'm going to treat it as I'm going to do one white on one sheet and black on the other sheet. All right, so for this now, but you can't take every turn anymore. So now sequence. So now let's see. This is the white sheet, but what is my first turn number, right? So if this is the white checker, then white goes on 1, otherwise white goes on 2. So that's my first turn is 2. I don't get all the dice anymore. I only get certain dice. So actually here, I'm going to do this. I'm going to do a sequence of up to 40 turns each player can take. One column starting at my starting turn and going by 2, right? Because I only go every other turn and my opponent goes the other time. And that I'm going to do on a different sheet. All right, so there I'm looking up the turn numbers that I, as the player playing the white checkers, get to go, which is those. This needs to be locked, which is why it's creating a circular reference. How about I do that? How about I do the whole little array? That's why I made it a sequence in the first place, right? And those roles I can't access anymore. So now I've got, you know, all this. This is the farthest it could possibly go. So I don't need all that anymore. This has changed though. Now these are not the right turn numbers anymore because this is not my start number anymore. I'm only going every other turn, so I multiply it by 2 in this case, and then I add the turn that I started on, right? And if I'm adding this, I need to take the integer part first, right? Because I can't double the 0.5s, right? So I take the integer part of this. Now I multiply by 2 and then add whatever my starting turn is, right? So this times 2 plus my starting turn. Yeah, 2, 2, 4, 4, 6, 6, 8, 8, etc. That's what I want. All right, so X lookup being done on here, returning on here. So this represents that the player playing white would win on turn 18, but it's not. That's not the only player playing the game. There's also a player playing back. So I create a totally new copy of the sheet. This is that. Now this is for the player playing the black checker, right? So I switch those. And also I have to switch the starting position, right? So it is going to be this, but I also have to reverse it because black goes the other direction. So 2 row x2 call, my lambda has a reverse in it. So gonna do, gonna do the reverse like that. And then this is when black would win. This is when white would win, right? So this is white, this is black, is these. And then the winner is simply whoever wins first, right? The lower number of these. 17 is the example. Let's see about the rest of them. They look good. All right, so we move on to level 4. This stuff is going to be different. This now, the only thing that's different is doubles now, right? So in backgammon, if you get doubles, so if this equals this, you get 2 more. So H stack, this, and this, right? A doubles counts as rolling the same die 4 times, right? Then that, otherwise nothing, right? So add that for my doubles, and now X2 call, right? X2 call is going to skip the empty strings for me and give me the doubles. So 5, 5, 5, 5. These that are not doubles, then 4, 4, 4, 4. All this. That's going to change my turn, though, for sure. So instead, I'm going to track in roll and then turn number. All right, so the first one is 1 always, right? That's your first roll. So if the previous roll was 1, then this one is 2. Always. If the previous right? So if the previous roll is 2 and it's doubles, meaning that this equals this, then the next roll is 3. If the last roll was 2 and it's not doubles, then you go back to 1. And if the last roll was 3, you always move on to 4, right? And if none of those are true, that means it's 4, so you go back to 1. All right, so let's see if that, 1, 2, 3, 4 for my doubles, 1, 2, 1, 2, 1, 2, 1, 2, and then here's my next doubles, 1, 2, 3, 4. So yeah, that's what I want. So the turn number, first turn number is given there. So if you are on roll number 1, then you raise the turn number by 2 because my opponent gets to go, then I get to go. Otherwise, it does this. So, your doubles turn 2, 2, 2, 2. This doubles turn here is, turn, you get, 4 of these here for this doubles turn. Is this lined up correctly? Probably not. Let's see, 4, 4, 6, 6, 8, 8, 12, 12. Oh yeah, this is 5, 4, and then you have 4, 4, 4, 4. Yes, no, it's fine. All right. Looking up the turn number that the player playing the white checker would win. Definitely not 2, because I'm not looking up any of the right stuff. All right, so looking up on here, returning here is 14 that the player playing white would win. Also have to consider the other player. So L4B is, what if this is black now, right? So this is switched. This has to be, basically the same as this, right? This thing reversed, which it is. So that is, and that's it for changing the number, right? So this is white, this is black. So equals all this. And then the winner is the minimum of these. 14 is the example. Let's see about the rest of these. All right, there's level 4. All right, so level 5. There's 4 different boards, and I'm not bearing off to start. I gotta move all these checkers out of the way. But they still don't interfere with each other. So I can still treat this as 2 separate 1-player games rather than really having a 2-player game. And this stuff's definitely going to be different. All right, so the issue that I'm going to have here is, let me see if I can do this ideally without crashing Excel. If I take this, I need 12 more spots, right? Because I need to have 18. So let's say I do that. I go that far. Like, ooh, mouse is off. Go. These 18 spots. White checkers cannot be in this space, those spaces, right? So there's the 18 spots. I got to look this up though, because there's 4 different boards now. So this board starts on 80, let's say we'll call the example 80, 86, 91, 96. So if this equals example 5, then we'll call that game 80. Otherwise, the game number is there. So now X lookup the game number on this game number table, returning, yeah, starting in 18 to the end. And it is exact match or next smaller item. So this, but we only count them if they're white checkers. So if the first checker, if the first item here is a white checker, then the length of that, otherwise 0. So there is the starting board. My furthest one is here. Let's say I can move these back to where they line up okay. All right, so that is the first 0, and then the space number is 19 minus that. So the first of these that is 0 is space number that is not 0, right? Is space number 10. So my farthest checker is 10 spaces away. How many do I have in my exact lookup? The what I rolled, right? I rolled a 5 in this case. So I looked that up, and there's 0 here on 5. My move rules have changed, right? Because I have a new rule, which is, am I bearing off? So I'm only allowed to bear off if the minimum of that is 0. If the maximum of that is 0, meaning all of these are 0. So if all of these are 0, that means this area is clear and I'm allowed to bear off. Otherwise, you can't start bearing off yet. So now my move rule, right, is if and I have something to bear off and I'm allowed to bear off, then I will do the exact bear off. Otherwise, I'll move the farthest one, which is 10 in this case. The 2 done is the same. The roll logic should be fine. Turn, the bearing off will be fine once I learn how to update the board. All right, move to, move from. Those are actually in good spaces already. I mean, is this just correct? Let's see. I moved the 10 out, but everything else is the same. Let's see, and I might have to go pretty far because there might be more doubles. Furthest distance. Yep, this has to go down, down, down here. We're probably getting pretty close to an answer here. So let's see what happens if I do my done lookup here and make sure I'm actually looking up in the right place, which of course I'm not. So the turn number on the done going down a little farther, let's say. All right, so white would win on 19, which matches the example. So hopefully I'm on the right track. This is going to be L5 black. So we switch this and this. The black stuff is this part and it's reversed, right? So I got to do this X lookup and I've got to do, 2-row X2 call all of this, nothing, don't do anything to it, but do reverse it. All right. Now, show address, reverse, parentheses, like that. So let's see if that matches this, right? So there's a 2 and 2, there's 1 and 3. Yeah, looks right. And then this is if it's a black checker. Right? No, I didn't do a black checker, but I can switch it. I think that'll work. Yeah, those are my black checkers. The white checkers are zeros. That is when this player would win. So now if I know when this player would win, and then I add when this player would win, let's do by row minimum. All right, 19 is correct for the example. All right, there is level 5 solved. Should have 1,000 points so far. Double check that. Yep. Bonuses. What is the pip count for these other boards? Well, I got a pip count counter right here in level 1. So I'm going to make this now bonus 1. And the boards I need to look up are, these for levels 2 to 5. There's 7 boards total. So here's board number 1, board number 2, 3, 4, 5, 6, and 7. So now, I'm only going to use that. Those are the boards I'm going to look up. Here's board 1. Let's say that equals X. I'm gonna get rid of this stuff and say X lookup the board number on the case, and then starting with the white 24, which is L through AI. So on case L through AI is this. Yeah, those are the checkers. And that should be the number of pips, right? I've handled my zeros correctly. Turn this on, but not like that. Turn this on, but based on the what if table input is now here. And I do, equals the sum of this, 1028. Total pip value of all the dice, 25 games of level 4, counting doubles as 4 times. So all the dice in level 4 is, B2. Let me just do X2 call everything from level 4 here, right? So level 4 starts here, goes what, to row 80? Like that. Die pips those. Let's do it this way, right? So if this equals this, then this plus this, right? That's the same as counting each one 4 times, I think. point. So the sum of this now is 16 through 82, correct? Wasted pips in the game, the level 2 games. All right, so in the level 2 games, you see here how you move. So you move from space 3 to space -3, right? Because you rolled a 6. Those are these negative numbers are our wasted pips, right? So what I do here is I make this B3. If error, I gotta rewrite all these errors here. So this, if error, nothing. Now equals filter this, where this is less than 0, right? Those are my wasted pips. So, you know, the sum of this times -1 is all my wasted pips. So I just point at my wasted pips, turn on the what if table, and sum these up. And that is Backgammon in 26 minutes, 40 seconds. Thank you for watching.